Today we are going to continue on where we stopped on ordinary differential equation. In the last class I gave a little introduction on what differential equations are and the types of differential equations we have, and we focused more on ordinary differential equation, where I told you that we have the first order differential equation, the second order ordinary differential equation, and we defined what degree and order was. So I ended up teaching on one of the techniques of solving a first order ordinary differential equation, which was by direct integration. Okay, so today we'll be doing separation of variables. So today we'll be talking about what? Separation of variables. So separation of variable is another method of solving differential equations. Now, if the first derivative of a function, say dy dx, is equals to a multivariable, say f of x comma y, where f of x comma y is a product of x of the function of x, g of x, and h of y, or the multivariable, which is f of x comma y, is equals to the quotient of the independent function of the independent variable to the dependent variable, say g of x and h of y. The equation is said to be separable and in turn integrated on both sides. That is, if the y dx is equals to g of x over h of y, for example, so that when you cross multiply, dy will multiply with h of y and g of x multiplied by the x, and it's what? Integrated on both sides. So this is practically the solution of what? Of our differential equation of the first order in this form. So there are two examples that I will solve based on this. So we'll start with example 1. Example 1 said if the y dx is equals to x over tan y, obtain y. So what is the function y? So we go a part, the y over the x is equals to what? X over tan y. If you look at this, it's just looking like this. G of x is x, h of y is tan y. So we can now say we are going to what? Put the y term together and x term together. So for us to do that, tan y we multiply with the y, just like a cross multiplication. So we'll be having tan y dy and is equals to what? X dx. So what do? We integrate, integrating both sides. We have integral of tan y and is equals to integral of x dx. So from our integral table, I said if you want to do anything first order differential equation, ordinary differential equation, it will all lead to integration. So you have to go back and learn your integrals. So integral of tan y will be log y to the base of e. Sorry, not log y to be log sec y to the base of e, and that's going to be equals to what? Integral of x dx is what? X squared over 2 plus c. So this is or in some books you can have it as ln sec y. Anyone can go, it's just the same thing. So we want to make y the subject. So that is going to give us, taking the antilog, natural antilog of both sides, we have sec y is equals to exponential x squared over 2 plus c, and we have sec y is equals to exponential x squared over 2 times exponential c, law of indices. And this exponential c shall be denoted by a constant. It's a constant, so we can denote it with a. So sec y is equals to a exponential x squared over 2. So therefore, we want to make y stand alone. Y will be arc sec a exponential x squared over 2. So this is what we are going to have at the end of the day. So this is the what function that describes this differential equation. So that's the first example. So what I will advise you to do is to go and study on your integrals. Very important, because integrals most times is the solution for first order differential equation. So integration is what you always end up with when you start with your first order differential equation of the ordinary form. Okay, so we move on to the second example, solving the second example. Alright, so the second example here says the y over the x is equals to x squared y plus y. It says solve for what? Solve for y. So we have the y over the x is equals to x squared y plus y. Good. Now, looking at this function at the right hand side, you will notice that it's not looking like a product. So what we are going to do is to what? We factorize. So what is the common factor? The common factor is what? Y. So when you factor out y, what are we left with? X squared plus 1. Now, looking at it now, it looks as like a product. It's a product actually. So what do? We will separation of what? Variable. That is, the y's come together and the x come together. So doing that, we have the y divided by y is equals to s squared plus 1 dx. What I did was that I multiplied here by the x, divide here by the y came down here. So we integrating both sides. We have integral of dy over y equals to integral of x squared plus 1 dx. So integral of dy 1 over y with respect to y is ln y, and is equals to what? Integrate this pretty much straightforward, x cubed over 3 plus x plus c. So taking the antilog, y is equals to what? Exponential x cubed over 3 plus x plus c. As usual, we can remove the constant. We have exponential x cubed over 3 plus x multiplied by exponential c, and exponential c itself is what? A. So y is equals to a exponential x cubed over 3 plus x. So this is the differential equation that governs, this is the solution for the differential equation dy over dx is equals to x squared y plus y. So that is pretty much everything you need to know when it comes to separation of variable. But for more clarity and understanding, you can solve more examples on recommended books like Engineering Mathematics by K. Strud, HK Das. They are highly recommended to use to practice more on this part of the course in ordinary differential equations.